Dear students, let us now talk about the basic principle of feedback. What's a feedback? What's called feedback? So it means it's a process of transferring of some part of the output signal or some part of the output energy into the input of a device. അതായത് ഒരു ഡിവൈസിന്റെ ഔട്ട്പുട്ടിൽ നിന്ന് കുറച്ച് ഭാഗം എടുത്തിട്ട് ഇൻപുട്ടിലേക്ക് തന്നെ തിരിച്ചു കൊടുക്കുന്നതിനാണ് നമ്മൾ പറയുന്നത് ഫീഡ്ബാക്ക് എന്ന് പറയുന്നത്. സോ ഇറ്റ് ഇസ് എ transferring a portion of the output energy of any device to its input. Now there are two kinds of feedback. One is positive feedback. The second one is, of course, negative feedback. Okay, so what is a positive feedback? If the feedback signal is in phase with the input, then the input signal boosted up, and such feedback is called positive feedback. Okay, so a positive feedback, in positive feedback the feedback signal and the input signal are in phase. Okay, so that means they get added up, so such feedback is called positive feedback. In negative feedback, okay, so if the feedback signal and the input signals are out of phase, then the input is reduced, so such feedback is called negative feedback. So it may be positive or negative. So in general, positive feedback is used in oscillators. So positive feedback in oscillators, while negative feedback is generally used in amplifiers. Okay, so positive feedback is used in oscillators, negative feedback is used in positive feedback is used in oscillators, negative feedback is used in amplifiers. Okay. Another classification of feedback is voltage feedback, then current feedback. Okay, so in voltage feedback, the feedback signal is proportional to the output voltage. Okay, in current feedback, the signal is proportional to output current. If the feedback signal is proportional to the output current, it is called current feedback. And there is compound feedback also. Okay. It is proportional to both in output voltage and output current. Then such feedback are called compound feedback. Okay, now let us talk about the feedback amplifier. Okay. So a feedback amplifier consists of, we have studied about the amplifier, common emitter amplifier. Now we are using a feedback part also in this, or feedback network also. So a feedback amplifier consists of an amplifier, an internal amplifier. Okay, so the block diagram I'm drawing here, along with a feedback network. Feedback network may be resistors, capacitors, inductors, etc. Okay, so a network of these components. Okay, so there will be, so this is the internal amplifier. Okay, here is the feedback network. Okay, so for the internal amplifier, there will be a signal, input signal. Okay, and there will be output from the internal amplifier. Okay, now a portion of this output is fed back to the input. Okay, so this is VO, here VO, here VI voltage is there, and this voltage is, and a portion of the feedback of sorry, a portion of the output is fed back to the input signal. So input signal is like this. Okay, so this is the block diagram of a, okay, so this is the block diagram of a feedback amplifier. So here input signal Vs is the input signal, Vi is the input signal to the internal amplifier, and Vf is the feedback voltage, feedback signal, and Vo is the output signal from the amplifier. Okay, so again, so Vs is the input signal, Vi is the input to the internal amplifier, Vo is the output of the amplifier, Vf is equal to beta times Vo. So it's a fraction of V only. So beta is less than 1. So here beta is termed as, beta is the feedback fraction, feedback ratio, or feedback fraction. Okay, so these are the different voltages shown here. So Vs is the input signal, Vi input to the amplifier, Vf is the feedback voltage given to the, along with the input signal. Okay, so the input voltage to the internal amplifier Vi is equal to Vs is the input signal plus Vs plus Vf. if it is positive feedback. If it is negative feedback, it is equal to Vi equal to Vs minus Vf. So it is either positive or negative. Okay. So accordingly it is called a positive feedback or negative feedback. Okay. Let us take the negative feedback first. Negative feedback. Negative feedback. In this negative feedback, then the input to the internal amplifier Vi is equal to Vs minus Vf. Okay. So here it is equal to Vs minus beta Vo. Now the gain of the amplifier without feedback is gain without feedback, that is given by A. Without feedback gain is the internal amplifier gain, so that is Vo divided by Vi. Okay, so Vo divided by Vi is equal to Vo divided by Vs minus beta Vo. So from this expression, Vi is equal to Vs minus beta V. Now rearranging this thing, you get A times Vs minus beta Vo is equal to Vo. Therefore, the gain with feedback, gain of the feedback amplifier or gain with feedback, this is given by AF. AF is equal to Vo is the output of the feedback amplifier and input of the feedback amplifier is Vs. So Vo divided by Vs is the gain, voltage gain of the feedback amplifier. So which is equal to, from this expression, so we can rearrange, this is A times, this is given by A times Vs minus A times beta Vo is equal to Vo. Okay, so from here A Vs is equal to, this A beta goes this side, A beta Vo goes that side, so this is 1 plus A beta Vo. Okay, so Vo divided by Vs from this expression would be A divided by 1 plus A beta. Okay, so this is the feedback amplifier gain, negative feedback amplifier. Okay, or it is the gain of the amplifier with the feedback in the case of negative feedback. Okay, so negative feedback. Okay, now for positive feedback, the internal amplifier signal, the input signal to the internal amplifier Vi is equal to Vs plus Vf. Okay, so this is equal to Vs plus beta Vo. Okay, so using this and rearranging the terms, we get the gain of the amplifier AF is equal to A divided by 1 minus A beta. 1 minus A beta. For positive feedback. Okay, for negative feedback, A divided by 1 plus A beta. For positive feedback, A divided by 1 minus A beta, where beta is the feedback fraction. It is not the current gain, it is the feedback fraction now. Okay, as we said earlier, The negative feedback is used in amplifiers, okay, while positive feedback is generally used for in the case of oscillators, okay. So the characteristic of negative feedback amplifier. Negative feedback amplifier, okay. Advantages of negative feedback amplifier. First one is it stabilizes gain. Okay, a feedback signal to the input stabilizes the gain, okay, because the input signal is in accordance with the output signal. Okay, so the input a portion of the output signal is going to the input, so it stabilizes the gain of the amplifier. The second is it improves the frequency response. Response improved. Response improved. Frequency response is improved. So it will have better frequency response if we use negative feedback amplifier. Instead of using a simple amplifier, we use negative feedback, then frequency is response is improved. That means we will have better frequency response curve. Next is it means it maintains a constant frequency response of a constant gain for many frequencies. Okay. Third point is it reduces noise. Reduces noise level. Okay. Then fourth one is phase distortion. It reduces phase distortion. Phase distortion. It reduces phase distortion. These are the different properties of feedback amplifiers. It stabilizes gain, frequency response curve improved, reduces noise level, reduces phase distortion. So these all are depending on the frequency of the. Most of them are depending on the frequency of the signal. Okay. So the input feedback amplifier in the feedback improves many things in the amplifier. Okay, thank you.